Thanks for joining us. We have an exciting opportunity here. I'll introduce the presenters and we will go from there. So again, we'd like to thank the University of Utah for hosting this event. And with the interesting, unique virtual opportunities that we have, we're happy to bring this to a broader audience. We are also recording this, so to the students and advisors, if you have individuals in your chapters that are unable to attend, we may be able to broadcast this to a larger audience in the future. So you all are familiar with me. I'm Education Program Manager and generally run the IPC Student Chapter Program. Charlene, I'll let you introduce yourself and we shall go from there.
Hi everyone, I'm Charlene Gunter-Duplessis and I am the Senior Director of the Ipc Education Foundation, and it's wonderful to bring this opportunity to all of you and to hear from our President and CEO, Dr. John Mitchell, about the industry. And I noticed that each one of you sent some great questions to Aaron, and we sent that to John, so he had some time to think about his responses, and I'm excited because I'll be learning alongside all of you.
I have a question.
Yeah, Rishi.
So is it possible, like after the webinar, we could have like a one-on-one talk or something like that?
With whom?
Like with anyone. We decide to talk.
Yeah. Well, let's connect with me after the event and we can set something up.
Okay, cool.
So for those of you just joining, we're basically, even though it's a webinar format, we're just turning everybody's microphones on and then just asking that you mute so that since there aren't 1,000 people on, we figured this way we could just chat as a normal Zoom type of meeting.
And then we also have Joe, I believe. Joe, you are the Vice President of the chapter there at the University of Utah. So thank you. Yeah, and thank you so much for welcoming our CEO to the campus and for making him feel at home. And it's unfortunate under the circumstances, like Aaron mentioned, with COVID-19, but we want to ensure that everybody is, keeping their distance, and you all had your masks on, so no one is breaking the rules. So just want to mention to everyone that they do have the 6 feet of separation happening, and we are very fortunate to have this wonderful, beautiful angle. But Aaron, if you want to start driving and ask questions so that we can learn from John and industry, that would be great.
So Joe and I have to catch up afterwards because I see he's got a Tour de France shirt on, and I just did a 116-mile ride here this weekend, and so we need to talk if he's a cyclist at all.
Right on.
Quite a ride. So John, do you want me to go through the questions, or did you want to start with something? How would you like?
Let me just open with a little bit about IPC and who I. So Charlene runs the IPC Education Foundation, and the foundation is set up to really help the electronics manufacturing industry connect better with those who are not already in the industry. Okay, and IPC then is here on behalf of the industry. Our members are primarily, they're all the brand names you would recognize, from the Apples and Samsungs to the Boeings and Airbuses, the Lockheeds, the GEs, the Huawei's, imagine just about any branded electronics company in the world. They're pretty much our members, but that's only about 20% of our membership. The other 80% of our membership is the rest of the value chain. So the people that do, you might get somebody on those primes that might design a piece of electronics. Then somebody actually has to go build it and manufacture it. Some of them do prototyping, some of them don't even do that. And so then you have like the assembly groups, the printed circuit board manufacturers, materials, and then equipment and suppliers that go throughout the entire supply chain. That's the membership breadth of the IPC membership. And so that's my job all day. We work in primarily 3 areas: standards. So IPC doesn't create standards. We work with the industry and industry experts. We all gather together and work in various working groups to develop the standards together. We shepherd the process, if you will, and then publish the standards. And then the second area is education. So we do a lot in terms of certification and credentialing and skills development in terms of what are the skills that various roles in the industry need, or the education piece. And that can be as focused as a specific job credential, or as broad as here's a specific type of technology or an interest or an area of concern, and we'll bring experts from across the globe together to talk about that. And the last area is advocacy. And so working with governments, as you look at the value chain of the electronics industry, you go from the primes to the assemblies, and as the farther you go down the value chain, the tighter margins get in terms of your business. And there are a lot of chemicals and dangerous things that you use to build electronics. Right. And so there's regulations and things that go on with that, and how they're used, where they can get transferred. Sometimes we get involved with tariffs and things like that. So we work with, we have offices in DC, in Brussels, and contacts in Beijing as well, trying to help bring science to bear on the legal system that's going to impact how electronics are built. So it's standards, education, and advocacy is really the three main things that we focus on. And we're trying to serve a $2 trillion industry with just a little bit of effort there. So we are a nonprofit. It's a volunteer-based organization, so companies send their engineers either virtually or physically to various meetings to try to work on all of those things. So that's the brief update, and there. Back to you, Aaron. I'll make it sound like a TV show.
I was thinking I was muted. How funny. Thanks, John. So I just want to remind everybody that if you have a question as we go through here, please use the Q&A chat. You're welcome to use the webinar chat as well, but I'll facilitate questions through the Q&A. So I'm going to jump into a few of the questions that we've had before. So let's see. This question is from Michael Saraso. I think he's actually on the line. Michael, are you here?
Hi, yes, I am.
All right, I'm gonna let you ask your own question. You asked about electronics.
Yeah.
Source. Go ahead.
Yeah, I don't remember exactly how I worded it, but I think what I've been and I know this is my own experience. Like, there's Adafruit and SparkFun, a lot of open source electronics companies that kind of create tutorials, and that's where I learn a lot about electronics myself. I think there's like an insecurity I have that this is all like hobby grade electronics, and that industry isn't so interested in that experience. And so I guess I'm wondering, like, how does like an Arduino developer elevate himself to a kind of electronics expert for industry?
That's a great question. So first, all of that experience is good. Getting experience even in what I would call less regimented or less industry you called it hobbyist, but I just think it's experience. So anything you can learn is helpful. When I was working at Bose, we interviewed literally thousands of engineers. And so those that have experience and can talk to that is helpful. It's not going to be always directly applicable because you're dealing with different types of applications. I'm guessing if you're doing a kind of your own board design, you're probably not doing a 64-layer board with high density electronics. So it's not going to directly apply, but it's going to, the same types of things are going to be applicable. So all of that experience is good. Someone who comes in and is a, kind of a hobbyist and has done those things and built things is going to have a leg up over someone who has done none of that. So don't despair that that's not useful, but you will continue to learn. I mean, engineers learn their entire lives. I mean, that's part of the goal. And so building on the fundamentals, you'll get fundamentals in class, you'll get fundamentals from learning projects and using these other platforms. So those are all good things. When I actually, in our senior seminar, I think it was our last senior seminar before I graduated with my electrical engineering degree, I remember the professors came out and they said, so we waited until this seminar to let you know that basically about 90% of the stuff that you guys have been memorizing, you'll never use again. And we're like, what? This is terrible, but really what you're learning to do is you're learning to problem solve. You're learning to learn and to solve problems. So all of that will have experience, and the more diverse your experience, the more you'll be able to leverage different thoughts as you bring it to it. So it's not a waste of time at all, but know that you will continue to learn throughout your engineering career. Does that answer your question?
Yeah, I think so. I think like that's really good to hear, because I don't know if I've ever heard someone exactly say like Arduino is like it's not worthwhile to do. It's just I think in the back of my head I know that, like, you know, a lot of these companies aren't using Arduino, they're using more complicated systems to build things, and so I wondered if it was even worth it. But
there are some
industry.
There's some industry level like software design packages that are available to students for free too. Some of the, you know, like if you're doing a board layout, if you're looking at that kind of design type of stuff, I know, what's the name of the company? And I have no interest here. I don't get any, but I believe Altium, like there's Mentor, Altium, and one other. They're typically the most popular software suites that are used in industry. And Altium, I believe, offers students free access. So you can get some experience with that as well as a tool. And they have courses available that may give you some insight or edge. So that would help you be more prepared for what you'd actually be seeing on the job.
Gotcha.
Indeed. Awesome. We did notify the students that Altium does have free student licenses. So
yeah, exactly.
Certainly. All right, on to the next one.
The access is pretty strong from what I understand there.
Yeah. All right. What are the emerging technologies that IPC is working on that we as students can learn from and grow in our careers?
Okay, so what isn't there? So where IPC focuses on is really on the electronics manufacturing set of activities, all right? So there's a lot of different standards organizations out there. You know, you have IEEE that does a lot on communication protocols with computers. So they're big into the IO2 dot whatever, you know, and different types of peripherals and things like that in terms of their standards experts. There's other standards developments like JEDEC that is more on the components, specifically on the standards of what it takes to have a specific, you know, for capacitors or passive components. There's SIA that does the semiconductor, you know, standards and things like that. So we focus on the manufacturing of electronics. So how you build it, put it together, because obviously the greatest design in the world, if you can't build it, isn't worth a lot. And being able to build it repeatedly and robustly. So some of the new stuff that you'll see a lot more focus coming on is we're calling it F2, or Factory of the Future. And so it's a lot about integrating AI, security, robotics, all of the, you know, some of those latest things you're talking about, the, you know, how will quantum computing impact how you're manufacturing? How will 5G communication change all of that? So the Factory of the Future stuff that we're working on there is probably the most future-reaching stuff that we're doing right now. And there's actually new projects being kicked off on that all the time. We just launched a standard a year or so ago called the CFX standard. It's the Connected Factory Exchange, which allows any specific piece of equipment to talk back and forth to each other and for you to gather data from. So you can basically build smarter factories. And you can build that on top of other protocols so that basically if you have an ASM machine and a Heller machine and a Fuji machine, they can all talk together and you can get the right data out of it and still use their special sauce, you know, that makes them unique. So Factory of the Future is a lot where, and that encompasses lots of different technologies that are going on. A lot of things that people are very concerned about is protection, IP protection right now, you know, and people think about IP protection, they think more along military, but it's really going to change to be, how do we protect the information, not just in cybersecurity, but even just in access. You know, people walking off with a USB stick and, hey, how do I protect against that? And suddenly my design is out there, or information, et cetera. So that would be probably the area that I think is most far-reaching into the future that IPC is putting a lot of effort in now. Our chief technologist, Matt Kelly, is leading that effort.
Okay, great. Thank you. All right.
Aaron, you froze. There you are.
Am I good? Moving a little more into a.
You're back. You were.
Oh, is my audio going in and out? I could switch off of the headphones.
You're good now.
Okay. Okay. All right. So, what professional development recommendations would you suggest for a third-year engineering technology student?
So EET, professional development. So that's a hard question to answer because there's so many options. You know, you can go, what do you want to do? You know, depending on where you're going, are you going EET? You're trying to get directly into, you know, there's different job roles you could go in. You could go into QA. You might want to move into factory management. You might want to do work into, so it's hard to say. It kind of depends on the path you want to go in. So in general, though, I would say try to get as familiar with what the options are in terms of the various roles that you could look at. And they range all the way from, you know, you could start off as an operator. Actually, my first job when I was in the electronics industry, well, I guess it was not quite my first job in an electronics industry in the factory. So I was in the research division that was tied to a factory. And we spent a couple of weeks actually working on the line because you need to understand how that works because there's limitations around that. So we did a little rotation there. I did some design work. I you know, did some rework, and you find out what you're good at, what you have a flavor for, what you hate. You know, personally, I wasn't one that could just sit on the assembly line all day long. I lasted for a couple hours, and then I was like, I would start wanting to poke my eyes out with hot pokers. But there's other people there that are doing very important work, and this is, you know, kind of their focus, and they move around. Oh, now I'm going to become a test engineer, and so they're focused on unit test or things like that. So it really depends on what you want to do. What I would do is, if I was a third-year student, I would first try to find people in industry that have job titles that are interesting to me, and part of what we offer in the networking area can connect you with people who are actually doing those jobs in industry. And I mean, it's a little tougher right now with COVID going on, but ideally I would have said, go to the factory, you know, go do some tours, get some experience, see what's going on. But a lot of the factories are kind of saying, okay, only employees only right now. But at some point, I hope that loosens up here soon, and get that experience, see what's going on there, and then adjust accordingly. But ask them. You know, as far as what IPC provides, we are actually, for specific job credentials, there's education tracks that you can go to gain more experience and get some credentialing and skills on that front. There's a lot of prelude to. We have some programs online you can take.
Yeah, it was open-ended. I'm going to ask you to elaborate on one aspect that I get a lot of questions on this from students. So you mentioned QA and factory management. What are some of those other tracks that students can pursue that they may not know about, you know, being students?
So inspection engineer right now is for EET is a highly sought after or needed position out there in industry. There's always need for QA. So where do we go? So test, I think I mentioned that as well. So a test engineer. So right now when we build electronics, they're in most cases fairly complex. And so you go through from the actual manufacture and inspection to the test, where you're verifying that as much functionality as you can, but you can't, usually for most complex devices, you can't do 100% proof out in the test, and then you move into QA as well. So those are kind of the build, test, QA, if you want to do very broad. But there's also pieces, yeah, there's also, you know, just management of the factory. That, you know, I had my brother-in-law said, hey, I'm thinking about becoming a double E. And I was like, well, that's great. There's a lot of options in electrical engineering. You know, you can do more technology side, you can do more design side. And with any of that, you know, I at the time when I was working at Bose, this was when he asked me, I laid out 12 electrical engineers in front of them. All of them were doing drastically different careers, had nothing to do with each other, yet they had the same basic degree. So you have a lot of flexibility in this industry to do different things. Some of them were doing purchasing, others were doing marketing, and yet more were, you know, I'm doing high-speed design, I'm doing, you know, factory logistics, you know. So it's really that problem-solving aspect as you go into this. And if you would like to do something more hands-on, you do something more hands-on. If you want to be more theoretical, you can do that. So the reason it's a tough question to answer is because there's so many options. And one of the things that we're working for in our education space is we gather together what we call JTA committees, job task analysis committees. And we pull people from industry, all across industry together, and we say, okay, what are the jobs you need that you just can't find enough people for? And they identified, like in this last one, the top 6. And even though they had titles, those titles can mean different things to different companies. So then you go through the, what does this title mean? And then we work with them to develop a program so we can start credentialing and then certifying people that you can just go take some courses, post-grad, pre-grad, et cetera, depending on the course. And you can say, hey, I'm an IPC certified this, and you can go get a job. Hope that helped, Aaron.
Yeah, that does a lot. Thank you. Okay, switching it up a little bit. So we do have a fair amount of students in our program pursuing associate's degrees. What benefits do you think can provide IPC to your associate's degrees students that want to go directly into the workforce?
So a lot of the community colleges and associate's degrees programs that I've seen, one of the biggest benefits is they actually will offer certification programs that IPC, that the industry uses from IPC. So you can actually be a certified 610. And if you're moving into the assembly space, that's very helpful, or certified to 600 if you're moving into the PCB space. And those are credentials that companies sometimes contractually have to have their employees certified to. So those programs are available at many community colleges, but they're also available at certification centers around the country and around the world.
Would you recommend that a student pursuing an associate's degree that does not come with an IPC certification go get a certification?
If they know the job that they're looking for, so if you know you want to go work in the PCB arena, getting a 600 certification will give you a leg up for sure. And those certifications get renewed every 2 years. So you might do it the first one yourself, but then after that, typically your employer will cover your renewals.
Okay, very good, thank you. All right, how did you get started and how did you carve out your career path?
We don't have enough time for that, but I started off as an electrical engineer. I worked for General Electric in the aerospace world initially, and had a good time doing that. Then I moved into the automotive space with Alpine, helped actually bring about these navigation systems that everybody uses on their phones now. Back in the day, it used to cost $3,000 and it only covered Los Angeles. But that was the first ones that we built there. And then from there, I moved into Bose, and then from Bose, after we were doing some pretty far out-reaching stuff, which was kind of cool, I actually moved into the nonprofit segment, and I ran a collegiate honor society, Golden Key International Honor Society, for a few years, and that was my nonprofit experience. And then the opportunity here at IPC came about, and it was kind of the juxtaposition of everything. It had electrical engineering, it had my international piece, because I'd always worked international when I was doing all of those jobs. It had my nonprofit, it had my business degree tied to it, and it had education, which I just got my doctorate in. So it was like the perfect storm of everything I've ever done, and so that's how I got here. So I didn't set out as an engineer saying, I want to run a trade association. I didn't even know what a trade association was. And in fact, even as an engineer, I wasn't even aware of what IPC was. I just said, you know, it was just like, well, it's one of those standards things. And I've become more aware, and we're trying to create more awareness about how we can help companies improve their business, become more efficient, create more reliable products, et cetera. But I wouldn't worry about having a grand vision. Have a vision 2 to 5 years out, you know, and go for that. Do something you're going to enjoy and be interested in. And if it changes, change. You know, even though I worked at some of those companies for over 10 years, I don't think I ever did the same job for more than 3 before I was changing and shifting to other things. So don't be afraid of change, you know, or shifting your passion as you go forward there.
And I have a question to go off of that. So coming from a more conventional engineering position in just running an organization, I'm wondering if you can comment on sort of parallels that you saw from the problem-solving skill set that is just inherent to getting an engineer's education, and what were some of the things that maybe you found yourself applying in a new way, and what were things that were just completely new making that step?
Yeah, so just answer that in 2 different ways. So first, in many larger companies, there is an engineering progression track and a business progression track. And in good companies, they're parallel. If you want to become an engineering fellow, it's equivalent to being a vice president in the company, which is kind of cool. If you really are, hey, I'm the engineering guy. Bose had that, IBM has it, Lockheed has it. Anyway, so lots of these companies have that kind of path, which is great. As far as the applicability of my engineering problem solving to business, it's directly applicable. All you're doing is problem solving in just about everything, it feels like, to me anyway. Yeah. So I did get a business degree. It's funny, when I was getting my engineering degree, I thought I would never get an MBA because those guys are just the devil. Yes. All they care about is money, you know, oh, that's just evil stuff over there. But as I got more experience as an engineer, I'm like, actually, even if I have the world's coolest idea, if I can't finance the thing and can't find people that are interested or to buy it, it just doesn't matter. Because I'm not a trillionaire sitting around where I can just go do all these projects. So adding the business degree was a nice complement to that. And I found I actually enjoy that as much. I still geek out a little bit, you know, when I get together with some of our engineering colleagues. So I enjoy both. But the problem solving aspects are very applicable. You're just dealing with a different set of conditions. Some of them I don't like, but you have, you know, in engineering, you have to deal with conditions as well that you may not like the limitations you're given, but they're either, you know, maybe you have a limited budget, maybe electrons will only go so fast, you know. But anyway, but the same typing of skills are applicable. You look at the boundaries, you assess the variables that you can control, and then the influences that are coming upon you, and then you try to draw paths through them that will get you to your solution.
Great, thank you.
Sure.
Very good. Thanks, Joseph. So I'll change gears a little bit. This actually correlates more with your previous answer. So what are the job opportunities, and if you know and are willing, job salaries for international students in the IPC industry? I mean, we do have a fair amount of international IPC student members as well.
Yeah. So there are lots of opportunities. I would put them into 2 buckets. I'll put them into engineer and technologist, okay? So engineering, right now when we do surveys, about 2/3 of our industry says they have trouble finding engineers that can fill their roles. And about 2/3 of them say that I think it's like 66% on one hand and 64% on the other. Say that they're struggling to finding people that can do more direct hands-on or technology type of work. So there are opportunities. It's a great industry to work in. I mean, I entered it and it was a recession. I still found a job, you know, so there's always jobs available for good people. The salaries are a little higher on the engineering track. So it really depends on the company and what you're doing as far as the salary goes. But at the low end, an operator job, if you just come off the street, have no experience, no degree, you can make about $14, $15 an hour, okay? Which doesn't sound like a lot since Amazon's paying 20. So that's a challenge that the industry faces. On the other side, with a master's degree and some experience, I think you can come in the 60s, 60K range on an engineering side seems reasonable. Does that sound like what you guys are hearing? I don't hire engineers anymore. I haven't done it for a decade. At least not right out of school.
Okay.
But the upside, I mean, I know people making an engineering track that are making, you know, a couple $100,000 a year easy.
All right. We'll save that for an industry member that maybe or can get some job data info. That'd be
what do you mean? A couple $100,000. Well, that was experience.
I actually did some research, John, on that, and just pulling up some of the slides in terms of an engineer. If you focus on the industrial engineer, and this is by the department, like the website that I used was www.bls, so .gov, so it's governmental. And linked to the Department of Labor. So industrial engineer current salary is about 91,000, mechanical engineering about 92, electrical and electronics engineer around 101, and chemical engineer 114. It all depends on your which is a bachelor's degree. Currently they list no work experience or on-the-job training related. So I believe it's in that ballpark. You can kind of take a 20,000 down maybe on that, but that's the information I have on that.
Location, experience, and those are typically averages, so they change depending on where you're at. But the other challenge, if you're back to this original question, Aaron, you asked about, if you're coming in, you know, from outside of the United States and trying to find a job here, is there can be some H-1 visa challenges in terms of getting working visas. And so that's probably the biggest limitation as opposed to jobs being available. And so most companies are willing to go through that process for you. There's opportunities that I've seen many of them go through there, but there are limited numbers each year available.
Okay, good to know. So we do have a question that was put in the chat. How helpful would taking the FE exam be in terms of future job prospects in the electronics industry?
I don't know what the FE exam is.
Maybe PE, professional engineering, maybe?
I don't know.
I don't know. Yes.
Mr. Silva.
Oh no, I'm sorry. Fundamentals of engineering leading into PE.
I've never heard anybody ask for it, but that doesn't mean it's not that. I have thousands of companies that I work with, and I don't know them intimately in all their job requirements either. So what I would do is I try to understand exactly what you're trying to get into. So if you want to become a PE, and as you're going and you're looking to move that path, and if FE will help you on that path, then fine. I never became a PE myself. Although I could ask Matt Kelly, who is a PE, and he may say that's exactly what you need to do. So I actually don't know the answer to that question.
Okay. We'll add it to our list. We can ask some more industry members.
Okay.
All right, I've got another here in the Q&A. Do you think there are more electronics design freelancers these days? Is the gig economy changing the electronics industry?
Yes and no. It's really easy to go out and design your own stuff now, which is awesome. There's so many great tools available, and you have an idea, go build it. And I'm a big believer in the entrepreneurial type of mindset. I think there's a job available for anybody who has a good idea, and then take that and find the right audience for it. Even if that's as a side gig for, a full-time paying job, that sort of thing. But make sure that you've covered yourself, because often when you sign with a company, you sign away all the stuff that you invent during that time. So make sure you sign the right things and don't give away all your IP just because of that. So I think it is changing it. The challenge is also that because it's so easy to do, there's so many people doing it, it's hard for anything to stand out, if you know what I mean. So whereas you might have had, Jobs and Woz sitting in a garage, and they could literally call up, and he called up the head of Hewlett Packard, right? He called up Packard and said, hey, I'm interested in this. Can you get me some of these parts? And he actually started talking to them. This is the president of the company. That's a little harder to do nowadays because they're growing so fast, but it doesn't mean you should give up. But it's just hard to get noticed. So it's changed it in that there's lots of people that can do really cool things. The challenge is how do you differentiate yourself enough so that, Elon gives you a call and says, hey, I like what you're doing with this electronic car thing. And we had, I'm going to forget his name, the CTO of Tesla come and speak at Apex 3 years ago. And basically that's how he met Elon Musk, is he was doing some cool garage stuff on building electronic engines for like low-level vehicles. And they liked where he was going on the science, and they went together and said, hey, we should make this company. And they created Tesla. So it can happen. It's just about, it's really about your desire and your dream to push it out. But don't be afraid to go make those connections. I mean, I used to teach a networking seminar where I literally said, who would you love to meet? Oh, I'd like to meet Barack Obama, or I'd like to meet so-and-so, or whatever. It doesn't matter. You can make that happen. There, is that whole 6 degrees of separation thing. It's real. You might have a connection where you go, hey, I know Aaron. Aaron, who do you know that might know this in the electronics industry? Well, let me go see, let me call John Mitchell. John Mitchell, I happen to know the CEO of that company over there. Oh, well, let me talk to him. Oh, he knows this CEO over here. Next thing you know, so I had a former colleague of mine. She was interested in getting on a board of directors at an electronics company that was based in Japan. 2 calls later, she was talking to one of these people. So don't give up on that stuff, but you have to know why, and it can't be just, hey, I want to go chat, because their time is valuable. And then when they give you advice, so this is the one thing. So if you go, as you go, and you should all be developing your own mentor groups, right? And they can be direct mentors or they can be virtual mentors. You can study about their lives. I mean, you could have, Mahatma Gandhi, right? As a mentor. That doesn't mean you're talking with them every day, but you might study what they did and they might mentor your life. So you can pick people that are unreachable or haven't reached yet. But you should all have mentors in your lives that are kind of guiding your careers or your thought processes, so you can bounce ideas off their experience. I used to mentor one student, and I told him, I said, look, I think I can save 3 years off of your 5-year career progression just if we meet, once a quarter for lunch and just give you a couple little hints about how to do it. And as he was doing an internship over that summer, he went from just starting off as a summer intern to actually on a project directly reporting to the CEO in the space of 3 months. And so it's just about, sometimes there's little things you can do that you just may not be aware of. And that's why you get this, suite of mentors that 3, 5 people that can advise you as you think about different aspects of your career. I've forgotten what the question was, Aaron.
We were talking about freelancing electronics, but that was a great chat. I'm glad you took the tangent. We do have a couple more questions, none directly from the chat, so these are previous ones. We've been told about the benefits of standard organizations, probably for me, but haven't used them much in class or in projects. How can we discuss standards in interviews and on our resumes to help us stand out?
So that's a great question. So I was actually surprised. I was visiting one university and I was trying to get a tour of their electrical engineering department, and they set me up with a grad student who was walking me around, and I said, oh, I work for IPC. He says, oh, you're with IPC? And he knew who I was. I was like, what? That's crazy. But in general, I don't think that's true. I didn't really think about standards as a student. You can actually, to me, one of the greatest things that you can do, you can actually join standards committees as a student. There is no requirement that keeps you out. So if there's a specific aspect of your career and you go, hey, I wonder if there's a standard about that, there's committee work, and you can say, hey, can I join? And now you may not be as a voting member, but you can be as an auxiliary member. You can become familiar with the process. And then when you interview, you can talk about that. So interviews, basically your grades and stuff is kind of like the key to get through the door. The rest is how you interact. And so having stories where you're sharing experiences of what you've done in the industry. So it could be, hey, I built this project on my own in my garage using these free tools. And they're like, that's cool. Tell me more about that. That's what I wanted to hear. You could also say, hey, I joined the standards committee. I was sitting on the blankety blank 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 standard, and I learned this thing, and I had some interesting questions about that. And most of these forums also have chat, and a lot of these folks that have been around for 20, 30, 40 years actually love interacting with students. They love if you're interested and have questions, so you can see the list of the people and say, hey, by the way, I had a question. You said something like this. I don't understand why that would do there. And say, hey, well, maybe I can set up a separate chat. Now guess what you got? You got a mentor, you got a recommendation letter, you got a reference, all that sort of stuff. So being proactive and reaching out to industry. Now you're not gonna get yes every time, but I'm guessing 70% of the time, if you ask a good question, you'll get somebody that's willing to chat with you.
Very good. John, could you elaborate a little bit more about what a standards committee is and does?
Sure. So standards committees are set up to create a consensus document that industry will agree to abide by because it generates better product or better process, et cetera. And most of these follow what is called the ANSI process, the American National Standards Institute, ANSI. So ANSI sets up the rules for under which standards get created for this country, and usually they're the ISO version for the US, okay? So ISO authorized ANSI, we follow the ANSI rules, and it's really we're following the ISO rules. That's a little hierarchy. But in terms of what it means is we say, okay, now here's the topic. Let's say there's the, I'll just pick one. We're trying to understand component placement on a board. So like machine is trying to place it, and what's good, what's bad in terms of solderability, in terms of reliability, in terms of connection, you know, all those things. And so there might be a standard on that, and you say, well, that's kind of cool. I'm wondering why that makes a difference. And so people who have interest in that topic then will find that standard and will reach out to, if it's an IPC standard, you can literally just go online and say, hey, I'm interested in a standard that works on this type of stuff. And they can say, oh, well, we have a standard that does that, and it's this one. We have committee meetings. Would you like to join? And then there's an online tool, and basically industry members will join. Not all of them are able to be on those meetings all the time, but it's usually about an hour to an hour and a half meeting, like once a month. And then occasionally, like twice a year, they'll do face-to-face meetings, but even that, not everybody's able to make it. You've got, 400 people working on a specific standard. Not everybody's making it to the meeting, so they might still have questions, but that's, I hope that answers the question. That's kind of how a committee, a standards process works. I used to sit on the ISO navigation map database committee. They asked me because I was building these things back in the day, and I was mostly an advisor to it, I was not the draftsman of writing up the final words, but there's a lot of advantage. You learn a ton and you can network a ton.
Very good. I have one more question. I think that we probably answered it. I'll ask it anyway. What are typical entry-level job titles and functions at companies in the industry? And just before, we do welcome any more chats if anybody has any. So entry-level titles, go ahead, John.
So if on the technology side, the entry level is operator, okay? You walk in and typically there's about a week's worth of training. We're trying to shorten that down to a couple of days with some new technologies that we've just started offering. And on the engineering side, it's usually just a junior engineer that you might start off as. And depending on where you're at, you may just come straight in and you'll do a specific job. Other things may have you shadow different people for a period of time so you get more general feel for it. The biggest need that I hear from industry with people both on either technology or from engineering side coming into industry is they said there's so much more they need to learn. I'm like, well, of course, they didn't, they went from lots of information in general to specific. But there is also a common thing about the general work environment, getting more familiar with that in terms of what they call soft skills. You know, hey, guess what? I actually need to be at that meeting on time. They really expect you to actually show up and show up to work on time and things like that. On the engineering side, it's a 40-hour-a-week job, but the expectation is it's 50. That's just kind of the thought. After 50, if you're getting, there might actually, in some of them, you might get some overtime pay. It might be available. But if you're salary, it might not. But just kind of go into that with that expectation that if you're putting in a 50-hour work week, you're probably doing about somewhere between 40 and 50. That's about right on the engineering side. More on the, when you're hourly paid, like when I first started with General Electric, I just went in as a junior engineer and I was getting paid hourly, which was kind of cool. And I actually made more than the general engineers because I was working more hours and because it was very regimented, and that my first 8 hours were at time, the next 4 hours were at time and a half, and the 4 hours were double time. And because my schedule was swinging, if I came in 2 hours early, I was making double time because it was the second shift or third shift of the previous day. So it was a big mess. It was kind of funny. I remember, you know, back in the day, an engineer was making about $32,000, $33,000 a year right out of school. I was making $1,000 a week as a junior engineer hourly. And I was just kind of laughing. They were like, this is ridiculous, Mitchell. What are you doing? I'm like, well, I'm putting in some extra hours and they're still paying me hourly. So it differs depending on where you're at. I hope that helps. Hold on a second there. Joe's got a question.
Yeah, Joe. Going off of that, I think while you're still a student in engineering, there's like a big expectation that you should get an internship by the time you graduate. That will give you a big step ahead. Yeah. And in some cases, it might even be like a requirement, depending on which direction you want to go into. And I was discussing this with someone the other day about my plans after I graduate and the companies I might want to work for. And someone suggested, well, hey, why don't you try getting an internship after you graduate? And I'm wondering if you can comment on, is that a feasible path, and what role does kind of the internship play to a student who graduated, and what would you comment on that?
Yeah, that's interesting. So first, internships are like gold, okay? Right. If you can get it, so if you can get an internship at a company that's respected in the industry you're trying to go to, that are known, you know, that's like they're like, oh, they get it. They kind of, I'm gonna save 3 weeks of training because they've already gone through it in the internship type of thing. They're gonna get what it's like to work in a place. So the value of the internship, I still believe in heavily. Internships after graduation, it just depends. So sometimes I find that that's a great option, especially if there's a challenge in getting work. You know, like maybe you're not looking for, maybe the ideal job has not shown up. Like, I want to be this and work for this company, but they're just not hiring right now. Their hiring cycle might not be for another 6 months. Don't do nothing. Go do that type of internship, and you can show some of that experience. For one, you'll learn more about what you like or don't like, and it will help you get the other job. So any experience you can get will be helpful. I guess that's how I would look at it. I wouldn't sit there and say, oh, I've got to go get an internship after I graduate in order to get this job. Because if you can get the job, get the job.
Right. Yeah, so it's sort of...
It's another option,
right,
is what I would look at it as. If you have a very specific target and you can't get that yet, do something that might lead you to that, even if it's just an internship or an interim position. You can look at it that way. I hear a lot from a lot of business people, oh, you know, today's generation, they just don't stay with the job for their lives, blah, blah. I'm like, well, the companies don't stay around for their lives either. So there was a great piece of data that I shared in one of the presentations I gave that basically said, you should be glad when somebody self-selects to go change careers. Yeah, you train them, et cetera, things like that. But having somebody that stays there that isn't happy is a really bad thing for your company. Mm-hmm. So you should be trying to learn and figure out what the best options are for you. Because if you're not a match for that company, go find a company that you are a match for, so that company will be happier, and then hopefully the person they bring in will actually be happy in the job that you were, and they'll be a better match. So it works out. I just would say, don't be afraid to change. I had a friend of mine said, hey, I'm thinking about taking this job, but they told me, the expectation is that you need to stay here for the next 10 years. I'm like, they can't even tell you that the company's going to be around for 10 years. How can they? I mean, they can put that pressure on you, and there is something to be said for loyalty, but somebody who's loyal and not happy is not going to be as productive or do as good a work. And so if you're enjoying, and that doesn't mean every day is good. It's called work for a reason. It's challenging, it's difficult. Sometimes you have to deal with garbage you just don't want to. Just because that happens occasionally doesn't mean, you're still moving toward something that you like.
Great, thank you.
Sure.
Thanks, Jim. So I'm going to take a little swerve here, and I suppose, is it all right if we go until 12:30 at max and close then, or?
With 7 more minutes? That's great.
Yeah. Okay. So do you think there would be a better new energy, like nuclear energy, that could possibly replace or compete with electricity in the future?
Yes. Wasn't it a yes or no question?
I suppose it is, yeah.
One of the things that I'm interested in, so when you start doing something, you get comfortable doing it, right, in a certain way. And that's when you get in trouble, all right? So the more comfortable we are doing something one way, the more likely that somebody's going to come at it from a tangential or a right angle view and say, hey, what about this? And blow up the whole thing. So I don't know about alternates to electricity per se, but we could use light. Back in the day, we talked about, light-based computers would be kind of super awesome. But I also think there are alternatives to materials that knows where it's going to go. I mean, right now we think about, we've got the printed circuit board, and rigid boards are kind of old school. They're still there, but now we've got flex and a lot of standards back to that question about what's new stuff. We have a whole division on printed electronics. If you want to start doing mobile or clothing electronics, we have standards for that too, which is kind of cool. A whole division going on that side. High power electronics for electric vehicles is another whole region that is challenging some of the ways that we always do stuff. So I think there are opportunities. The yes is that there are always ways to do things differently. There's momentum to overcome though. And this is why IPC works in standards education and advocacy. So for instance, there are a lot better fuel sources than coal. And the technologies have been around for a decade or more. Yet you've got a very strong and powerful coal industry. Like if you look at Australia, they could be putting out these basically wave generated electricity. As long as there's a moon, they would have power, okay? And it could completely replace all their coal in their country. Yet the coal monopolies there have enough power to governmentally keep them from being replaced.
Political.
It's a lot of political stuff. So as much as I hate it, it's a reality. So there are always opportunities, but there may be challenges even if you have a great idea. I mean, I was a big believer. So back in the day when DVD just came out, there was a competing technology just before Blu-ray came out called FMD-ROM, which was 50 times better than DVD and like 10 times better than Blu-ray. Problem was Toshiba, Sony, etc., didn't back FMD-ROM. It was actually used the same laser pickups as well. You didn't even have to change it. So it was a vastly superior technology, but it didn't have the right support, and nobody's ever heard of it now.
Right.
So it's gone. So technologies are an interesting mix. So sometimes you have to partner with the big guys in order to get that technology to take the light of day. So, but yes, there are tons of opportunities for replacement technologies, especially in the materials space. Light, we've still got a little ways to go to replace electricity with, but so I don't see the electron getting replaced right away. with photons, but maybe somebody will come up with a telepathy electronics. I don't know. Mind-powered electronics, man. It's awesome.
All right, I'm going to pose one last question. You may have already seen this. Are there any pitfalls you personally ran into or saw colleagues fall into as they began their careers coming out of college?
So I've seen a lot of them. I hope I didn't do too many of them. So one is on the, like on the soft skills thing we were talking about. You got to show up, you know, be there. One of the other things that you can, so we have some younger engineers that have joined committees, and they were, I met some of them at our Apex 2 years ago, and this one specific, she was from Blue Origins, right? You guys know Blue Origin is, you know, it's a space technology company. Yeah, cool company. But she had joined the space, some of the space addendums of our standards, because there's different levels of standards. So you can say, here's how you should assemble something, but assembling something for a toaster versus assembling something for a cell phone versus assembling it for a car versus assembling it for a space shuttle all has different types of requirements because the environment is drastically different. So it's the same standard, just different revisions. So she was sitting in the space addendum committee meetings, and I said, are you asking? She goes, I got lots of questions. I said, raise your hand, you need to ask. And it's okay to ask. So one of the pitfalls I would avoid is not asking questions. Don't take over the meeting, but feel free to ask a couple of questions and share a couple of ideas. Say, how can we do it this way? Because most often I found when new or younger engineers or people in the industry ask a good question, it's challenging to answer because you just assume you know the answer. Oh, we've always done it this way. That's the worst possible answer you could ever receive. You really need to know why, because if they say that, that means they don't know why, or they haven't, or they just have no time for you. Go ahead and ask that question, because when they ask that question, you'll get to the fundamentals. The other thing that I would encourage you to do is to, not necessarily, in every meeting, because you don't want to disrupt the entire flow, but inside conversations, the other pitfall is not to understand the fundamental concepts, right? What are the base building blocks about why we're doing what we're doing? And that can actually lead you to new ideas. The other thing was be a problem solver, okay? A lot of people, you'll go into work and you'll see people complaining about, a lot of people might complain about a similar type of thing. Instead of just jumping on that bandwagon, think about how could you change it? And if you can bring ideas to change, be the idea person, you know? The one that comes, I'm the person that wants to try to make something change or become better. If you do that, you will find that you can progress very, very quickly. And ask, especially as an engineer, asking good questions is the sign of intelligence and somebody that you go, okay, they're asked, that's a really good question. And the idea that there are no stupid questions is true early. It's less true late. So you have to learn from your questions. Asking the same type of stuff that says you're not listening means you're not listening. The other thing that I would do, and this is just kind of an interview hint, that if you were interviewing at Bose, and we interviewed, like I said, we interviewed with thousands of engineers. How long was there? 6 years. In the 6 years I was there, I interviewed myself over 2,000 engineers. Okay, so it's an engineering company, you know, MIT blood flows through the place, you know, it's just how it is. Engineers hold 85% of the positions across the entire company. So engineers are marketers because Dr. Bose just liked the way they think. But when we were interviewing, one of the things that we always said is that we always highlighted for people, that the candidates that were doing a good job, they said, and they went to the whiteboard. So it's like, you'll be interviewing and say, you know, they'll ask you a question, how would you go about doing this? And you start going, well, you know, do you mind if I use the whiteboard? And you start sketching out your ideas, and suddenly people are like, oh, this is great. I can visualize. I'm getting visuals with Audible, and this is all. It connects. So find multiple ways to connect. You can use stories, you can use Audible, you can use visuals. So Those are some of the pitfalls I would avoid in interviewing and as you start off. But to remain silent and to not do the basics of, try to understand the culture. That's the other thing. Ask questions about what's the work culture like. In some places, shorts, t-shirts is awesome. Other places, you might have to dress like me. And I know that might be a pain in the butt, but it's part of the culture. So understand the culture of it as well. I'm over. I'm sorry, Aaron. I talked too long.
Not a problem at all. More time is more value to the students. That's how I view it. Okay. Well, thank you, John. Thank you to Joseph, the University of Utah, for being our gracious host, for all the students joining in, asking questions. That is, I'm going to wrap it up. Thanks, John. Get some virtual claps for John, or if you want to unmute and say thank you, you're welcome to do that too.
Thank you. You guys are all, I think you're all live now, so thanks, you guys. Appreciate you joining us.
Thank you, John. Much appreciated.
Very good. Thanks, everybody. Feel free. We welcome you to join future webinars, and if you have follow-up questions or anything like that, reach out to me. All right. I'm going to close it out. Thanks, everyone.
Thank you.
Bye.
Bye.